Hey, I thought I'd give you a little bit of information regarding sequences and series. Okay. Now, sequences and series, and why would you even want to know them? I mean, they seem kind of boring when you first see them. They don't seem very useful. But as is usually the case in math, it becomes much more useful later on. Okay. Probably one of the most important questions you might want to ask is, like I said, what's so useful about them? Well, here's just a couple of real quick examples. Have you ever seen this? Probably. You might have or might not have. But what I'm writing here, okay, and if you notice, none of the numbers are repeated. Okay, and if you add them in any direction, 276, 15, 951, 15, 438, 15, 618, 15, 753, 15, 294, 15, 258, 15, and 654, 15. That's pretty cool, right? Yeah, I like it. Okay, and this is a series, okay, or a sequence. I'm sorry, a sequence, and we usually call this the low shoe square. It just goes with low shoe square. And there's another one that's also pretty famous, and that's that's this one. Just look at this. You got a circle. You got a question. What is the maximum number of slices that you can cut something with a certain number of cuts? For example, with one cut, okay, you can cut it into 1, 2 pieces, right? Now, what about with 2 cuts? What is the maximum number of pieces? Well, it seems pretty simple. Just 1, 2. So you got 1, 2, 3, 4. Right? What about with 3? Well, you might be, well, remember, think about this. If this was a contest to see who can make the most pieces, would you win? Well, if you're like most people that just don't think very creatively, you're probably just going to say, well, let's just do 3 simple slices. And what do you get? 1, 2, 3, 4, 5, 6. Now your more creative friend might realize that you can do this in a better way. Okay? And you can do it like, you can say 1, 2, 3. Now you got 1, 2, 3, 4, 5, 6, 7 slices. You got one more. Is it possible to get even more from just 3 cuts? I don't know. You try to figure it out. The point is, though, this is a sequence, okay, and it's pretty famous, okay. As a matter of fact, it begins with no cuts, and this is 1 piece, this is 2 pieces, this is 4 pieces, this is 7 pieces, and in theory, the next one with 4 slices is going to have 11 pieces maximum. Okay, and this we call the lazy caterer's sequence. And I know you don't really need to know it, but the sequence is P stands for the maximum number of pieces, so this is P. P is a function of n squared plus n plus 2 over 2. Now this whole thing to you who are a beginner looks really fancy and scary, and really it's not if you just follow it through with a little bit of faith. For example, we can go over the simplest one, which is n well, of course, n is the number of cuts. So p is the number of pieces, n is the number of cuts. So for example, in this, we'll go to the simpler examples. The 4, well, that's got 2 cuts. So that's n. And the pieces is what we want to know, right? So we just write it as p equals, so wherever we have n, we replace it with 2. So that's 2 squared plus 2 plus 2 over 2. And that's going to give us, okay, 4 and 4 is 8 over 2 equals 4. Simple enough. Go one more, just to show you how much fun this can be. 3 cuts. And you see how easy it is? It's actually not that bad. It's just that when you look at all the letters, it looks fancy, but it's not. Don't let the math geeks fool you. Okay, this one, well, just 3 squared plus 3 plus 2 over 2. Okay? And that, of course, is 9, 12, 14 over 2. And that equals 7. So I'm sure you can see that if we do the math for this one, it's going to give us 11. And every time. So this is a formula that we can use. In this case, if we wanted to cut a pie into like 25 cuts, you would never know how to do that without using a sequence. Well, actually, you would, but you'd have to do it so manually and it would take you so long. You're just going to hate life while you're doing it. So that's why sometimes we create sequences, because sequences can give us information that we may need for a much later date. Okay? And that's one of the most useful aspects of sequences. These 2 sequences that we are using here, we usually call them arithmetic sequences. Like arithmetic. Okay, yeah, I know we say arithmetic because when we use the word arithmetic as an adjective, we pronounce it different. Don't tell me, I didn't make the rules, I just follow. So these are called arithmetic sequences. Okay, there's another kind of sequence, and this one, for example, I will show you. Okay, see, memory usually is in base 2. For whatever reason, it's in base 2, or we calculated base 2. There's many reasons. Let's not get into the complications. Let's just look at the numbers. Okay, for example, you might have 2 bytes. Okay, and then your next step up might be 4 bytes. Okay, and the next step will be 8. The next will be 16. The next will be 32, and then 64, 128, 256, 512, 1024, 2048, and so on. I know it's fun doing it, but I gotta cut sometime. Okay. Now, why is it? These are known as geometric. Okay, so these were arithmetic. These here are called. In a geometric sequence, it's unlike arithmetic sequences. You can tell arithmetic sequences because they usually are the difference between the numbers are added or subtracted. So you can add by the same number to get to the next number, okay? Or add or subtract to get to the next number. This one is usually a ratio of the numbers. Okay, so for example, let's look at this one. So this one is 2, 4, 8, 16, 32, 64. Okay, so let's look at this. 2 over 4. You can do it in either direction, by the way. People say do it in one direction. 4 over 2, doesn't matter. Okay, and what's this? Okay, well that's 1/2. Right? Now let's do this. 4 over 8. 1/2. 16 over 32. Are you seeing a pattern here? I hope so. 128 over 256. 1/2. Oops, 1/2. Okay. The point is that a geometric sequence can usually be distinguished by getting one and the next number, or the one before it, and setting them up as a fraction. You know that just means a ratio. And they're usually going to be a ratio, and it's always going to be the same ratio wherever we grab the first and the next number. Okay, look, 10, 24. So anywhere we grab it, the number and its next door neighbor will always be 1/2. Or we do it backwards. 5, 12, 10, 24. Same thing. So the point is, a geometric sequence will usually be a ratio. That's usually the way you can tell the difference. Arithmetic should be simple because it's arithmetic, adding and subtracting. Geometric is usually a ratio. Quick way to tell them, that's probably the easiest way to tell the difference between them, okay? Okay, now one of the things I should have made sure I don't go too far ahead, okay, is that as far as we've been talking right now, we've just been talking about sequences, okay, sequences. Now I want to give you the difference between, so we already said arithmetic is usually, the difference between numbers is added or subtracted by the same number, by a constant. For example, 1, 3, 5, 7, 9, 11, you can tell that the difference between these is 2. Okay, and then geometric, okay, these are a ratio, which you can also just call it multiplying or dividing. It actually gives you the same results. If you can't notice that, do it on a piece of paper. This is one of those things where maybe you should do some of that work on paper too. So don't just listen to what I'm saying and be like, huh? Try it and you'll see. Okay, but it's, again, it's multiplied or divided by a constant value. For example, with 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32, and so on. You notice where I got that from? Okay, that should be pretty easy for you to note. Okay, so this is what you call, this is the type of sequence or series. Now the next thing we want to talk about is series and sequences. Okay, right now you should know we've been talking about, now a sequence you should know because you've heard the word before, but in math it means exactly the same thing, which is just a bunch of numbers. And they usually grow or decrease. They usually increase or they decrease at a specific rate. So for example, if you were to plot them, you would notice that your numbers would either go up and you could trace a line, or they would go down and you would trace a straight line. Okay, that's a sequence. The next one up is what we call a series. And a series is just the sum of a sequence. Just a quick example, you got 1, 2, 3, 4. And if we call, usually series, we will usually denote it, by the way. Let me just put that here. Okay, your sequence, you're usually denoted by a to the n. Okay, n is in little lowercase. Okay, and series, we will usually denote it by s to the n. Okay, so here we will say the series of these four numbers. Okay, 1 plus 2 plus 3 plus 4. You should know this. It's 10. So S4 equals 10. Okay, and a sequence is just giving us the numbers. So A of 4 of that same here is just going to be 4 because we're just asking for the fourth number in that sequence. Okay? the terms are unnatural to you because you're just getting used to seeing all this garbage. Just like everything else, in time, it's going to start to become more natural. And let me tell you what, you're going to see it a lot. It's best if you get used to it, because the sooner you start getting used to this, the better you'll do later on when everybody else is crying about how hard this is. And by then, it'll be more natural to you. So don't shy away from this. This is really, really important. Okay? So, let's move on. Okay, so sometimes we're going to want to know what is the value of a certain number in a sequence. And usually it's not a small sequence. We may want to know the 1013th number in a certain sequence. And to just write out the numbers is impractical at best. I mean, we may not just want to know the 1013th. We may want to know the 1,003,117th number. Okay, we may want to add that one to the 737,000th number. The point is, it's impractical to just try to write out the sequence and figure that stuff out. Instead, we can use formulas. And the two formulas we can use, okay, are either the recursive formula or the explicit formula. Now, the recursive formula you can usually tell, because recursive just means that it uses a formula, it relies on a previous formula. To be recursive means that it points back to something in the past. Okay. Usually you're going to know that it's a recursive formula because it's going to have an initial value. Okay. And then it's going to have some formula with usually an n value, which is the number that you're looking for, and some formula here. Okay. Your explicit formula, on the other hand, is going to look different in that it will not have an initial value because it doesn't need it. That's why it's explicit. It will tell you exactly the value that you need by using some formula here. Now, it does not look the same. These do not look the same. Okay, do not make that mistake. They do not look the same. They appear like this, but this one, okay, will have an a value. Let me erase that just so you'll see. This one will usually have some sort of an a value. So, for example, a1, and then some calculation you do to it. For example, plus 2. That's just as an example. This one, on the other hand, will have the actual value, and then it will have the number that you need. Okay. So you might need it to be a1, and then you might have some operation. Plus, actually it would be plus 1 to the 2 or something like that. Okay, they're not going to look exactly the same. Okay, what might make it easier to understand is an example. Okay, so let's go ahead and do a quick example. I think that should help. Okay, so let's go ahead and look at this. Let's do this one, which is the easiest of the sequences. Let's do the sequence 2, 4, 8, 16, 32, 64, 10, 24. Okay? So, let's go ahead and do it both ways. Okay? So, first of all, we need to know a few things. Okay? Now, we're going to use terms here. Okay? R, okay, is what we usually call the common. Oh, by the way, this is a geometric sequence. So, this does not apply in arithmetic sequence. Okay? So this is a geometric. Now, R is called the common ratio. Remember I told you about that. Okay. And we're going to call A1 the initial value. Okay, so in this case, okay, our initial value quite clearly is 2. Okay, and our common ratio is 2. Well, our common ratio, in case you didn't notice, is what you multiply to get from here to here, from here to here, or if you divide them, either way. Okay, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that's the common ratio, right? Okay. So we have enough to start. Let's go ahead and first do, okay, we're going to do this recursive. We're going to we need first the initial value, okay, and that is A1 equals 2, okay, and the formula, now sometimes you're going to be asked to make your own, so notice this, it's not too hard. If you look at it, you can kind of figure it out, and that is, okay, A to any value, that's what N down there means. N means whatever number you have here. So in this case, okay, you might see N, well, let me give it a different value, a different color, so you'll just keep that in mind. Okay, N is just the number in the sequence, or in this in the sequence. So this is number 1, this is number 2, this is number 3, this is number 4, this is number 5, this is number 6, and this is N. Any value. Well, this has some value, but you know, just okay. So we have this here. Okay. So our second formula, this is our first formula. Our second formula is going to be a to the n, and it equals a to the n minus 1 times the common ratio, which in this case is 2. Okay, or we can, I'll give it to you more generally so you can see. Okay, so, and this just turns out, once again, to be a to the n minus 1. N minus 1 just means the number, whatever number you're looking for here, minus 1. Okay, times, and the common ratio we already said is 2 in this example. Okay, so for example, let's say we want to know what is this number here. Okay, well that number is number 4, so we write this like this. We write this a of 4, okay, and the formula tells us that it's equal to a of n minus 1 times 2. That means that it's going to be a of 3 times, sorry about that, I said minus, sorry, times 2. Well, what is a of 3? Well, a of 3 is 8. 8 times 2 equals 16. So as you can tell, we got our answer. Okay? Now, let's go ahead and do it the other way. Okay? Now we're going to do it explicit. Okay? And explicit, as I said, you don't need 2 formulas. This one did. Okay? You know, this one needed this one and this one. Explicit, we only need 1. Okay? What formula do we need? Well, not that hard to note, but what we're going to do is we're going to say a, it always begins with this a to something, a to the n, okay, and that equals the initial value, okay, which is a to the 1, times, and I'm making this one up, okay, not every formula will look like this. What they share in common is that it's just one formula, okay? So in this case, it's going to be a to the 1 times r, okay, to the n minus 1. And there's that whole fancy n minus 1 thing. I know that just drives you crazy, but once you've done it enough times, you're going to start to get the hang of it. So it's not that fancy, okay? So anyway, in this case, okay, we can just kind of write it out. Well, what is a of 1? A of 1 is 2. Okay. And what is r? Well, r is 2, right? Okay. N of 1, n minus 1, we don't know what it is yet, so we're just going to leave it like that. So we call it n minus 1, right? So that's what a of n equals. A of n equals 2 times 2 to the n minus 1 power. So let's go back to the same example. Okay. So we want to figure out a of 4. Using that same formula now, the explicit formula, we say, okay, 2 times 2 to the 4 minus 1 power. Well, what's 4 minus 1 power? The third power. Okay, that should be simple enough. That's 2 times 8. And lo and behold, we got the same number, 16. So there are two different ways of doing it. Just each one relies on a different strategy. Okay, let me just not use that same color. Okay, so one of them will do it in a single formula. The other one will do it using 2. This one will do it in a single. The other one will do it with 2. So if you ever can't tell the difference, just remember that explicit uses one formula. Recursive uses 2. It needs an initial value. This one doesn't, well, it kind of technically does have it in there. But you notice we just have a single formula. 1 equals, okay? So hopefully that helps you out, okay? What I'll do, if you need it, is I'll give you a few examples, and we'll see it. We'll take it from there. Okay? Okay. Thanks a lot.